Hello kids and welcome to today's lesson. It's on velocity. So very similar to speed, but a few different nuances. So the first thing we're going to do is we're going to take a look at two words, two vocabulary words that are very important in physics. The first word is scalar or scalar, and the second word is vector. And you need to know the difference between the two because they're very important. So a scalar quantity has magnitude and size and no direction. So magnitude is a word like 20 meters, for example, 20 kilometers, 20 grams, 20 kilograms, no direction, okay? And you'll understand that a little bit more when I give you an example of a vector quantity. Examples include time, mass, distance, and speed. Vector quantity has both magnitude and direction. So that's important, and this is important. So this would be 20 kilometers an hour west. We have this. We have a direction here. Examples include displacement, velocity, and force. Now we don't know, but we're going to spend some time today on displacement and velocity. So they compare to distance and speed. So, you guys understand distance. If I attach a direction to the distance, it's called displacement, with a few other differences. Speed is something like meters per second, whereas velocity is meters per second south. So there's an element of direction there. So what is position? The position of an object is the separation between the object and a reference point, which is usually 0 on the scale. So in this case here, there's our reference point. The position of car B is 1 meter to the left of the reference point. So it's moving to the left and 1 meter to the left, okay? So we have some direction there. And the position of car A is 8 meters to the right of the reference point. So here's your reference point, and we see that car A is 8 meters away from the reference point to the right, whereas car B is 1 meter to the left. Now, on a number line, when you're moving left, it's negative, right? And when you're moving right, it's positive. So it's a positive value and a negative value. Think about that for a minute. Since we stated that the direction, position is a vector quantity. So we use the word position to kind of give you the idea that direction is a thing. So let's talk about distance. Distance, on the other hand, when we're comparing distance to position, distance, on the other hand, needs no frame of reference. So there's no location, there's no direction. You measure the distance between two objects by measuring their separation. So all we're doing is we're measuring what separates either the two vehicles or this separation from a reference point or the separation from vehicle A to the reference point, but no location or no direction. Car A is 9 meters from car B, no matter where you put the reference point. So we don't say car A is to the right or to the left or anything like that. And since we did not state the direction, distance is always a scalar quantity. Always, because there's no direction. What is displacement? Displacement is another word that you don't know yet. The displacement of an object is defined as its change in position relative to where it started. This is displacement. So the car has moved a distance of 5 meters. However, the displacement of the car is 5 meters to the right, whereas the car has moved a distance of 5 meters. There's no direction. Here we have the direction. Since we stated the direction, displacement is also a vector quantity, whereas distance is a scalar quantity, and position is also a displacement quantity. Okay, let's take a quick boo at exactly what displacement and distance is. So if I look at distance, if these are steps, It's the total amount of steps that this person took, okay? So they would start here and they actually moved and took this many steps. That's your total distance. Okay, and there's no direction. If we take a look at just this reference point to this reference point, that displacement is just this area here, and there is a direction with that, and we can say southeast or whatever, depending on what the picture's trying to tell you. So here's an example. The difference between distance and displacement. Here's our reference point here. So if you take a look at the distance traveled by the person is 3 meters plus 5 meters. So this person traveled 3 meters to the right plus another 5 meters to the left for a total of 8 meters. Okay, so this is the total distance traveled. The displacement, on the other hand, is a little different. It's the displacement of the person relative to the bus stop, which is your reference point. Well, let's think about this. They traveled 3 meters to the right, right? And they traveled 5 meters to the left. So what you actually kind of do is, okay, since the right is a positive value, and then we add to the left is a negative value, so we actually add a negative 5 meters, and that's going to give you a total of negative 2 meters. Okay, this is what's really important. We use these signs here for the calculation. This implies a negative direction, the negative. So you have two choices. You either put negative 2 meters or 2 meters to the left. Okay? This is the best answer or this answer, but this is your best answer. This from the textbook is a little misleading because you don't have this if you have left, because it's redundant. Okay, so either negative 2 meters, because the negative implies that it's a negative direction, or 2 meters to the left, because the left implies a negative direction. So let's talk a little bit about vector sign and conventions. When using vector quantities and formulas, we do not write the directions using words. We use positive or negative signs when you're doing the calculations. So positive and negative directions. Forward would be a positive. The word forward is positive, that makes sense. Backward is a negative. Up is a positive. Down, obviously a negative. Right, left, east, west, north, south. So get accustomed to kind of evaluating a direction in terms of negative and positive to do your calculations. So what is average velocity? Now we're taking a look at average velocity and not average speed. With average speed, we look at distance and time. With average velocity, we look at displacement and time. So now we have a very similar example. The displacement of the car is 5 meters, right? So that's your magnitude. This part is your magnitude. To the right, there's your direction, and there's your time. Now moving to the right is the positive value, right, kiddos? So the average velocity of the car is defined as a change in position during a time interval. It is called an average velocity because it does not take into account speeding up and slowing down, so like average speed. But with average velocity, we take a look at the displacement. So notice that this is very similar. This formula is very similar to the speed formula, except you have this little arrow here. And these little arrows are telling you that it's a vector quantity. So it implies direction, whereas with average speed, those little arrows were missing. So we use little arrows to indicate vector quantities. So average v with a little arrow on top is velocity, not speed. And your delta d with an arrow on top is displacement. And obviously your change in time, notice that there's no vector there, there's no arrow, which means that it's a scalar quantity always. Let's take a look at an example. So here we have our, see, you notice that because it was moving to the right, it's a positive for your calculations. And when you actually go ahead and do the math, you'll notice it's 4.2 meters per second to the right. If you didn't have to the right, you'd have to say positive 4.2 meters per second. This implies it's moving at in a positive direction. You either have this as an answer or you have that as an answer. Either one is okay. Okay? I'll erase that so you can see. Since we stated the direction, average velocity is a vector quantity. Average speed is a scalar quantity. Average velocity is a vector quantity. So here's some examples. A student walks 10 meters east in 7 seconds. Then he walks another 12 meters east in 8 seconds. Determine the displacement. So for the displacement, we're going to go positive 10 meters plus a positive 12.0 meters because it's east and east, right? If I add those up, they're both positive. I'm going to get a displacement of 22.0 meters. Okay, the displacement of the student in 15 seconds is a total of 22 meters. The average velocity of the student, so write our formula over change in time. Our average velocity is equal to our displacement, positive 22.0 meters, over our time, which is 15.00 seconds. We use our calculator to get 1.4666 or 1.47 our units, meter per second. Now here's the key, east. That's your answer. If you don't put east, you have to put positive 1.47 meters per second. That is your other option. This is your best option because it gives you more information to the east. If I said, hey, move over there 50 meters to get me some water, it could be in any direction. If I say, hey guys, can you travel 10 meters north from where I am to get me some water? You'd be like, yeah, sure, no problem. I know exactly what you're talking about. So let's see, we're good. Let's look at another example. A student walks, let's change it up a bit. The student walks 10 meters west in 7 seconds. Then he walks another 12 meters east in 8 seconds. Determine the displacement of the student in 15 seconds. Cool. This time, west is a negative direction, right? So we use negative 10.0 meters. We use the negative sign because we're calculating, plus 12.0 meters, and that's east, so it's positive, and that's going to get you positive 2 meters, or 2 meters east. But we use this for the calculation, right, kiddos? And the average velocity, oh, darn it, I shouldn't have put that in there. The average velocity of the student. Now, for velocity, we're using this formula. Distance, so it's displacement over time. And that's going to give you, this time it's 2 meters, right? Over 15 seconds. And that's going to give us 0.13 meters per second east. That's your best awesome answer. And if you don't have that as an option, it's positive 0.13 meters per second, because this implies a positive direction. And what is the average speed? Speed is equal to distance over time. Speed is equal to, this time we're talking about distance. With distance, we take a look at the total. We don't care if it's going west or east. We're looking at the total amount traveled, which is 10.0 meters plus 12.0 meters. That's going to get you 22.0 meters over 13 seconds. And you guys recall what that is. 0.147 meters per second. But I wanted to show you the difference between a displacement question and a distance question. So here we go. A boat travels at a velocity of 8 meters per second north. That's a positive direction, right? For 14 seconds, what is the displacement of the boat? So it's asking for the displacement of the boat. If it just asked for the magnitude of the displacement, you would just give me something in meters or meters per second, whatever. If it's just the displacement and not just the magnitude, I need direction, okay? So let's write down everything that we have. Speed is equal to, or velocity I should say, because it has a direction, 8.00 meters per second north. And we have our time, which is 14.0 seconds. Remember, time is a scholar always. So then we are definitely looking for our displacement. Not distance, we're looking for displacement, so we have to have that little arrow on top. So let's go ahead and write our formula. Velocity is equal to change in displacement over change in time. Let's make this a linear thing, so I have to multiply that by change in time, and then multiply on one side as the other. It's equal to change in time times our velocity. Now we are looking for distance or displacement, so we're good. So our change in displacement is equal to 14.0 seconds times that by 8 meters per second north. Okay, so the seconds cancel out. You see that, kiddos? So our displacement is equal then to 112 meters. And what's our direction? Our direction is north. Okay, let's move on to the final example. An airplane is flying at a velocity. We see the word velocity. We know that that implies a direction of 900 kilometers an hour west. Travels 400 kilometers west, so that's our displacement because of the west. How long will it take? Will the plane be in flight? Okay, let's write down everything that we know. We know our velocity, so make sure you include that little arrow. It doesn't have to look like a perfect little arrow. 900 kilometers per hour west, right? And now we know that our displacement is equal to 400 kilometers west, and we are looking for our time. Let's go ahead and write down our formula. Speed is equal to, or velocity I should say, our displacement over time. Make it linear. Our change in temperature times our velocity is equal to our change in displacement. We are looking for our time. So now we have to isolate our time. So we have to divide this by velocity. Let me just rewrite it so it looks pretty. Change in displacement over velocity. And our displacement is 400 kilometers west, and our velocity is 900 kilometers per hour west. Let's see what cancels out, kiddos. The west cancels out, and the kilometers cancel out. And what are you left with for units? Hours. If I use my trusty calculator, 0.444. Usually I go to 2 decimal places, but that's okay. Hours. No direction, because time does not travel in direction. Okay, awesome, good job. I think you guys are getting this. So position time graph Looks exactly like a distance times graph. Looks exactly the same. Uniform motion. However, the only difference is the use of a direction. So, to repeat, the only difference between distance time graphs and position time graphs is that direction is included. This means that the slope is equal to the velocity. So if I take the slope, I'm actually looking for the velocity, and of course, the direction is north, which is a positive value. That's it, kiddos. I'm just posting a little bit of practice, and also I will be posting when you're going to have your next quiz. Your next quiz is only 5 questions, and it actually includes a little video. So have a nice day.